Welcome to this VMware and Intel demonstration showcasing the use of RAN programmability to unlock revenue-generating slicing for communication services providers, or CSPs. The business scenario is as follows. Imagine a CSP's enterprise customer wanting to launch a new service. Connecting through the CSP's BSS, this enterprise customer negotiates a service level agreement, or SLA. To fulfill this agreement, the CSP creates a RAN slice composed of multiple cells that will be governed by conformance to the desired SLA. So far, so good. But how can the CSP assure this SLA? And can the CSP assure this SLA while optimizing resources utilization in the slice? VMware and Intel's proposal uses RAN programmability activated through VMware Distributed RIC to monitor and dynamically control resources available in RAN slices to meet the negotiated customer SLAs. The concept is simple and effective. Based on the real-time traffic conditions per cell reported through Intel FlexRAN software libraries, the XApp and VMware Distributed RIC change allocated physical resource blocks, or PRBs, on each cell to guarantee the per UE minimum throughput while ensuring that resources are used in an optimal fashion. To establish the impact of this proposal, in this demo, we are going to compare two scenarios. One without any type of intervention to control RAN slice resources, and one with VMware Distributed RIC and XApp working together to guarantee the RAN slice's SLA. Our testbed is composed of the VMware Distributed RIC, integrating Intel FlexRAN software and APIs, and deployed on latency-sensitive Kubernetes worker node. The Intel FlexRAN software-based DUs, providing RAN functions emulation and E2 termination endpoints. These DUs are connected to a traffic generator, simulating UEs under different radio conditions per cell. Lastly, and integrated through the VMware SDK, we have a demo XApp from VMware executing the RAN slice PRB allocation algorithm to guarantee the SLA. Let's activate this testbed. With the testbed up and running, let's proceed with our scenario without RAN programmability activated. The main scenario conditions are a 30 megabits per second SLA per UE for a 100 megahertz carrier bandwidth. The Grafana dashboard displays the measurements that are being reported through the Intel FlexRAN E2SM KPM libraries. The bottom chart shows the PRBs allocated to the slice's users per cell. We see an identical and constant PRB allocation to the three cells due to the non-intervention of the XApp or VMware Distributed RIC. Because of this PRB allocation strategy, and due to the variable UE presence across the cells, the top chart shows a highly variable user throughput, with some UEs in the slice not being able to meet the SLAs, while others are benefiting from service levels above the negotiated 30 megabits per second. With this environment, the CSP cannot guarantee the SLA to the enterprise customer. Now, let's see what happens when we activate RAN programmability to dynamically control RAN slice resources. For consistency, Scenario 2 features the same conditions as in Scenario 1. The Grafana dashboard now paints a different picture. Based on instant traffic demands, the XApp algorithm calculates the PRB allocation corrections needed to guarantee the SLA. These corrections are communicated to the DUs through VMware Distributed RIC in the form of E2SMRC control commands, producing the PRB allocations changes per cell seen in the bottom chart. These dynamic PRB allocation changes, in turn, produce the changes in the per UE throughput seen in the top chart. As we can see, the reported minimum throughput for the UEs in all three cells is now always above the 30 megabits per second mark. Moreover, the minimum UE throughput across cells converges to a similar performance value, thanks to a more intelligent use of the available resources. The results are clear. Thanks to VMware Distributed RIC and the XApp, all UEs throughput values meet the SLA, and RAN slice resources are optimally used when and where needed. To summarize, in this demo, we have seen how deploying VMware Distributed RIC with the Intel FlexRAN reference architecture immediately delivers key technical advantages, such as visibility of slices performance, control over network and user-allocated throughput, and maximization of radio resources utilization. CSPs can now build revenue-generating models based on enterprise customers' business preferences and differentiate service offerings through SLAs.